Hello, physics. Today topic is dual nature of electrons. Usually dual nature of light is being discussed. Light behave like a particle in some experiments like a photoelectric effect, and light also behave like a wave in a double slit experiment, diffraction, interference. So these interference and diffraction is the evidence of light behaving like a wave. And the photoelectric effect is the evidence of light uh, behaving like a particle. But in electron, it have a particle nature as well as wave nature. When electron behave like a wave, they make interference pattern in double slit experiment. And when there's a particle, so certainly there will be two lines you can be observed on the screen. So simple experiment, we can see this one. So this double slit, if you fire bullets, so only those bullets will be appear on the screen which has passed through these slits, and other who are not passed through this one, they will be blocked. So at the screen, you will see the two lines or two bands. Similarly, when experiment was performed with electrons on the double slit experiment, it was seen and observed that there was a series of scattered bands or interference pattern was formed. So that is indication that electron was behaving like a wave. But on the other hand, when if you put a detector here, if it is a detector D, if you put a detector here, and then you observe that what will be the pattern on the screen, you will see there will be no interference pattern. There was only two lines on the screen. When just you have placed a detector in order to know that whether which electron is passing through which slit. So that may be that the why that the nature of interference of screen has changed. Then maybe that a detector, any disturbance uh, from the detector have caused this change of behavior from interference to bands. So the pattern was changed from uh, uh, particle behavior to wave behavior. So wave behavior when interference, and then bands, that's a particle nature. So when we use double slit experiment for the wave, we can have some set experiment where we can use the crystal so that the it split the photon into two. This experiment we will discuss it later, but now we use a single electron double slit experiment, one electron at a time. So this blue electron when is passing through for the slits. So there was no other electrons. So later on, that green electron comes to and pass through the slits. After a long time, so a photographic plate was observed, and the result was there was interference pattern seen on the photographic plate, or alternative bright and dark fringes was observed. That is the evidence that the single electron is passing through two slits at one time to form the interference pattern. So in order to know that which electron has passed through this one, and they used the detector. They used detector to know which electron has passed through which detector. So there was a detector at the slit 1, and there was a detector on slit 2. So detector recorded which slit which electron has passed through. After a long experimental result No interference was observed, that there was no interference pattern, and two lines were observed. The detector may be disturbing them in this way. So this was uh, that mean when you observe the passing of electrons, they change their behavior. If you are not looking at it, if you're not observing them, like this one, they behave like a wave. When you are observing them, they behave like a particle. And we will discuss later on more in detail.